Hey guys, this is a lesson about relations and functions, which is chapter 7, section 1, and the Big Ideas textbook. We're going to talk about the inputs and outputs. So the input typically is known as the x value, and the output is the y value. So if you have an equation like this, where 3x plus 5 equals y, you're going to be asked sometimes to put in, that's why they call it the input, to put in a value for x. Once you know what x is and you put it in here, you're going to get the answer for the y value. Sometimes the inputs and outputs are already labeled for you as x and y ordered pairs. So this is the input and that's the output. Okay? So if you have, for example, 3, 1, the 1 is the output, the 3 is the input. Okay, this is called a mapping diagram, and we're going to talk about a relation that these values have with that value. And the relation would be the actual ordered pairs that we're going to create with this. So remember, these are the inputs and the outputs. The input is known as the x, and the output is known as y. So all you would have to do is create 1, 2, 3 ordered pairs using this mapping diagram. So the first value of x is 0. When x was 0, the output became 2. When x was 1, the output became 3. When x was 2, the output became 4. Okay, in this mapping diagram, it looks a little bit more complicated as different values are matched up with different outputs. So the input would be 0. Remember, this is x and y, so this is x and your y. When the input was 0, it was matched up with 4. Next one, when the input was 1, it was matched up with going up to 5. But that 1 is also matched up with something else. It's matched up with 3. So we're going to list that one more time because it's matching up twice. Once here and one more time over here. 1 is matched up with 3. And the last one is 2 is matched up with 2. And these are the ordered pairs. So we should have 1, 2, 3, 4. 1, 2, 3, and 4. Alright, in the next part we're going to determine if all of these relations are functions or not functions. So the definition of a function is in a relation, and this is a relation, that's a relation, so we have 3 relations here. Each input has exactly one output. So each x value should only have one y value that it's paired up with. Again, each x value should only be paired up with one y value. Each x value should be paired up with one y value. Let's check on the first one. 0 is paired up with 2. 1 is paired up with 4. 2 is paired up not with one y value, but with 2 y values. So over here we can tell that each x value is not paired up with one y value, it's paired up with 2. And therefore this is not a function. In the second set, it's a little bit more difficult to see all the lines here, but -2 is paired up with just 2. -1 is paired up with 1. 0 has only one partner. 1 has only one partner, and 2 has only one partner. Okay, now we're going from left to right, checking on these. So each one of these was only paired up with one number. -2 with 2, 0 with 1, 0 with 0, 1 with 1, and 2 with 2. None of these x values had 2 partners. So this is a function. We would have to say yes. And the next one, -2 is paired up with 4, no other partner. 1 is paired up with 3. 0 is paired up with 5, but it's also paired up with 6. As soon as you notice that that one x value is paired up with two y values, this is not a function. Okay, once again, we're going to go back to these diagrams to see if these are functions or not. Every x value can only be paired up with one value, y value. 0 is paired up with 1, 1 is paired up with 4, but 2 is paired up with 6. The other way we can see this is by taking these values and plotting them. So we have 0, 2, 1, 4, 2, 6, and another 2, 7. So 0, 2 would be 0 and up 2. 1, 4 would be 1 and up 4. 2, 6 would be 2 over, up 6. And 2, 7 would be 2 over and up 7. So what you notice here is these 2 points, if you perform a vertical line test, right here, going straight down, they are going to intersect each other. Everything else, this point has nothing to intersect with, and this point has nothing to intersect with. So the other way to tell is if you put a vertical line through them, and they intersect through that vertical line at those 2 spots, at least 2 points, it is not a function. This one is not a function. Let's try the other one. The ordered pairs are 0, 3, 1, 5, and 2 is matched up with 4. So we plot them 0, 3, 0, up 3, 1, up 5, and 2, and 4. Alright. Now if we perform a vertical line test through any of them, this one does not cross with any other point, this one does not cross with any other point, and this one does not cross with any other point. And therefore this is a function. This is, yes, it is a function. Alright, let's look at this diagram here. So we're given the number of tickets and the cost, and we have to determine if this is going to be a function. So remember, these are x values and these are y values. Every x value should only be paired up with one y value. This one should be pretty easy to tell. This one has 1, this one has 1, and this one has 1, and the last one has 1. So therefore, yes, it is a function. If the problem asks you to describe the relation between the number of tickets and the price, well, you can see that all of these are going up by 1, by 1, by 1, and these are going up by 3, by 3, by 3. But what is the relation between the tickets and the cost? So as you buy 0 tickets, you pay $0. As you buy 1 ticket, you pay 3. As you buy 2, you pay 6. As you buy 3, you pay 9. From here to here, you can tell for every single one of these, it is multiplying by 3. So it looks like each ticket costs $3. So your explanation could be that it is $3 per ticket. The cost is $3 per ticket.